This is problem number 35 on the Chapter 1 test review sheet. And when we went through this section of the chapter and doing the homework, we had a lot of questions. The scores really weren't as high as I thought they might be on this particular topic. So I thought I would just walk through this one with you and see if maybe this helps, just give you another look, and then hopefully you'll go back through and you'll try it again on your own sometime before the test to be ready. So I'm going to actually do this in both ways. So this is going to be the substitution method that I'm about to show, and then I'll go back and I'll do the same thing using elimination. There is some crossover between these two methods, but I want to make sure you understand each. Now on the test I'm going to let you choose, but you may have already chosen to do a particular method, and I want to make sure I get both of them covered. So substitution. We need to target a variable, either one of these x's, one of these y's, or one of these z's, to solve for, or to, in other words, to isolate. And the one that looks like the easiest, where I can stay away from fractions, it's not too tough to get done, that would be solving for z in this third equation. Okay, so I'm just going to do it in a couple of different steps. Solving for z looks like this. It starts with negative z is equal to, I'm going to have to add 5x, I'm going to have to subtract 3y, and there's already negative 17 on that right side. Now I haven't solved for z yet, but I can easily by either thinking multiplication or division by negative 1. So that's going to turn this equation into positive z is negative 5x plus 3y plus 17. Okay, so I have solved for z, and substitution basically says this: solve for one of the variables, and then we're going to go in and replace that variable in the other two equations. Alright, so I'm going to show that being done. Here's equation 1, here's equation 2. So here's replacing z in equation 1. 2x plus 4y minus 5, and now here I go replacing z with negative 5x plus 3y plus 17, and that equals 18. Right? I'm going to split this up, and now over here I'm going to replace z in equation number 2. So negative 3x plus 5y plus 2, and then here I go again replacing z with negative 5x plus 3y plus 17, and that equals negative 27. So let me just take a quick look. Got to be really careful. It's easy to kind of zone out for a little bit, and then you look up and you realize you've made a little bit of mistake, and those little mistakes will really cost you in this. Okay, I think I'm doing pretty well so far. So at this point I'm just going to remove the grouping symbols, distributive property, combine like terms, and bring this down into a two variable equation, and I'm going to do that on both sides of my line. So 2x plus 4y, distribute negative 5, that's going to be plus 25x minus 15y, and then if you need to grab your calculator here, 15 or negative 15 times negative 5 times 17, that is negative 85 equals 18. Alright, gather up your like terms. 2 plus 25x is 27x. 4 minus 15y is negative 11y. And we need to move constants over to the right, so we're going to be adding 85 to both sides, and that's 103. Okay, let's do the same thing over here on the right. Negative 3x plus 5y. This is going to be negative 10x This is going to be 6y. This is going to be 2 times 17 is 34, and all of that equals negative 27. Gather up your like terms. Negative 3 minus 10 is negative 13x. 5 plus 6y is 11y plus. And then this needs to go to the right side with subtraction. So when we subtract 34 from both sides, we get negative 61. Okay, so these two equations that remain, you can see they're both in terms of x and y. They go together as a system. And this works out really well because at this point we are back to elimination. And this sets up really well for elimination because I automatically eliminate the y, as you can see, with addition. Okay, all right, so the process is take the two remaining equations after you've substituted, put them together as a system, and use elimination on one of the variables. And that's going to give us 14x. And over here we get 103 minus 61. And that's 42. So we get our value for x, our first variable we solve for is 3. X is 3. Okay, we'll write our answer as an ordered triple. Well, the next variable that we will solve for is y, and we're going to plug into either one of these two equations, doesn't matter which, and replace x with 3. Okay? So let's just go with the top equation. 27 times 3 minus 11y is equal to 103. 27 times 3 is 81. And let's just go ahead and do this. We're going to be subtracting 81 from both sides. So 103 minus 81 is 22. Negative 11y is 22. So that means y is negative 2. All right. We are 2/3 toward our final answer. We got 1/3 left. And at this point, we need to go back, and it makes sense to go to this equation that's already solved for z, since we need to find z. And we're going to replace x with 3, y with negative 2, and we will have our answer for z. Z is negative 5 times 3. Plus 3 times negative 2 plus 17, negative 15, and you could do plus negative 6 plus 17. Negative 21 plus 17 is negative 4. Alright, and so we found our three values for the variables, and if you wanted assurance, if you have time on the test, you could plug these in, and they should make each one of these true when you replace the variables x, y, and z with these numbers. Okay, so that's the substitution method. Let's take a look at elimination. Okay, how is it different? Well, with elimination, I'm going to come up with two pairs of equations. And I'm observing which variable does it look like would be the easiest to eliminate, and I hope you recognize that the z variable would be the easiest. So I'm going to pair up, let's just number these 1, 2, 3. I'm going to pair up 1 and 3 with the idea of eliminating z, and then I'm also going to pair up 2 and 3 with that same idea. Whatever variable you eliminate, you must eliminate the same variable within each pair of equations. Okay, so here I go. I'm going to do equation 1 paired up with equation 3 and then over here I'm going to do equation 1 again. One of the equations will have to be used for each pair. Here's equation 1 again. And this time I'm going to pair up with, sorry, I need to back up. Sorry about that. I did 1 and 3, so this time we're going to do 2 and 3. Because that would be the easiest way to eliminate z. Okay, so, and just typical elimination procedure, we need to, let me make a little bit of a space here because I'm going to need to multiply this bottom equation in each case by something in order to force elimination. So a lot of you like to create opposites with these terms, so I'll do the same thing. I'm going to multiply this bottom equation by -5 on both sides. I'll just show this. So -5 all the way across, and we'll do that in red. That gives me 25x minus 15y plus 5z. And if you do 17 times 5, you get 85. Okay, and I'll just mark this out so we won't have to look at it. And now we're going to eliminate z with addition. Okay, so this gives me 27x. 4 plus -15 is -11y. And then 18 plus 85 is 103. Okay, in a similar way over here I need to multiply this bottom equation by 2 in order to eliminate z. And that gives me -10x plus 6y minus 2z, and that's -34. Don't forget to multiply by the constant as well. Alright, so eliminate z with addition. -3 plus -10 is -13x. 5 plus 6 is 11y. And then over here we get -27 plus -34, which is -61. Okay, so this looks familiar, I guess. We're going to take these two equations and we're going to eliminate a variable. And maybe I'll just get to a certain point and it's just a repeat of what we did before. The y's eliminate automatically with addition, so we get 14x, and then again over here, let's see, this is 42, so we got x is 3. And so now we go back just like we did before in the substitution method, and we replace x with 3 in either one of these to get y, and then just like we did in the previous example with substitution, we take our two values for x and y and plug in any of these three original equations to find z. So you already saw the final answer. We're going to get the same answer with elimination as we did with substitution. But a little different way of starting with elimination. They are different to a point. After a while they both become elimination, but the way they start off quite a bit different. So I hope that helps you out, and if you need any other help, feel free to email me or come by academic support.